Hello, welcome to my coursework on applied AI coursework. So my topic of focus is email and spam filtering. Basically, the application of AI techniques in email and SMS spam filtering. So overall, spam detection is an important real-world problem. A lot of unsolicited messages people get. So they can cause security risks, financial harm, and a lot of inconvenience. So I'll be showing how AI techniques are used to distinguish legitimate and spam messages. So in part A, my focus is once again on the field of email and spam filtering. There's my focus literary review on it. So overall, I've said early spam detection systems were basically reliant on mainly rule-based filters, which limited their abilities to distinguish between spam patterns. So research by Sahami and others introduced basically probabilistic models such as naive Bayes models. This basically significantly improved the classification accuracy by basically learning from the data provided. And there are later approaches, obviously. There was incorporation of some machine learning techniques such as logistic regression and support vector machines, combined with feature extraction methods like frequency inverse document frequency, which is TF-IDF. But however, recently as well, there's been more studies on deep learning, in like that focus on neural networks, recurrent and convolution neural networks, which are basically can capture semantic and contextual information in texts. However, today is still quite reliant on traditional machine learning models, and yeah, basically still to this day the traditional machine learning models are still popular because they're efficient and they're quite interpretable and have quite a lot of stronger baseline performance. So moving on to part B. In part B, I basically evaluated 3 AI techniques that are applicable to spam filtering. First is the multinomial naive Bayes, which is basically a probabilistic classifier that assumes basically conditional independence between words. Is quite computationally efficient and performs well on short text messages. The second technique is logistic regression. Logistic regression, which basically models the probability of a message being spam using weighted text features. It gives good accuracy, but it requires quite more computational resources. Part 3 is deep learning. It captures complex language patterns, but it requires quite a lot of data sets and high computational costs. Upon like evaluating it, the best technique it seems is the multinomial naive Bayes, which was basically selected because it's quite efficient and suitable for data sets that are used. Moving on to part C. In part C, basically I focus on system design and prototype implementation. The system follows a standard machine learning pipeline. SMS messages are loaded from a data set, pre-processed, converted into numerical features using TF-IDF, and then classified using a multinomial naive Bayes model. The database basically consists of labeled SMS messages, which are either split into spam or ham, and the data split into training and testing sets using 80-20 splits. So Yeah, so the TF IDF factorization is applied to convert text data into numerical feature vectors. So the naive Bayes classifier is then trained on training data and evaluated on the test data. The output of the system includes classification, predictions, performance metrics such as accuracy, precision, recall, and a um, confusion matrix. So yeah, here's all the stuff. Here you can see my confusion matrix. Here you can see my accuracy data table, and so on and so forth. Part D, basic my testing and evaluation. In part D, the implementation was tested and evaluated using standard machine learning metrics. I achieved a 96.8% accuracy, um, indicating a strong performance. Confusion matrix shows that all legitimate messages were correctly classified, while a small number of spam messages were misclassified. So precision for spam detection is particularly high, meaning that models predict spam and is almost always correct. This is important in real world applications where false positives normally impact users quite badly. These results obviously demonstrate that multinomial naive Bayes is an effective, reliable approach when spam detection. Uh, so going on to part E. In part E, I basically considered the equity, diversity, and inclusion and sustainability of it. There may be a bias if the data set does not represent diverse language styles or cultural expressions, potentially leading to unfair misclassification. Ethical considerations also include user privacy, as SMS messages may contain sensitive info. From a sustainability perspective, multinomial naive basis computationally generally not too heavy and quite energy efficient. It requires minimal processing power and making it suitable for suitable AI deployment. Or, I think overall it balances performance and the environmental impact as well as the fairness quite accurately. So overall, in conclusion, I think I've demonstrated how AI techniques can be applied to spam filtering using practical machine learning methods. Multinomial naive Bayes has been shown to be the most effective and interpretable and sustainable solution for SMS spam detection. So thank you for having a look at my coursework one, and yeah, thank you very much.